Right. So the last class, I think we have come to a conclusion. What should be the minimum voltage that I should provide so that I could take under the category of small signal amplifier. What we derived is the VGS which we are trying to give, it should be very less than that of the overdrive voltage which you have given for that particular amplifier. If this condition is being satisfied, immediately what happens, you can bring that to a small signal amplifier. For a small signal amplifier, the linearity principle will work on. So I can use the linearity for that function y equal to mx plus c, so that it becomes an amplifier. Right? Now for the same amplifier, I am just taking the same amplifier, like common source amplifier. So on that we are given an AC signal, and for biasing we have given a DC signal. So I give this as capital VGS, small VGS for the AC signal which I am trying to amplify. Let RD be my resistance at the drain and VDD be the supply voltage. V suffix D be the output voltage, right? With reference to ground, that is source. This point is nothing but VDS. So this small letter V, the suffix capital DS indicate it is a summation of both AC and DC, correct? Now what I am planning to do, let me find out what is the gain being involved in this circuit. Right? Very simple. How do I get this VDS? VDS is VDD minus ID into RD, correct? Where again I can replace this I suffix capital D by, it's a summation of two current, correct? An AC current and DC current. So small I D plus capital ID into RD. I can write like this, correct? Again you can still simplify this as ID into RD here, minus small ID into RD. Can I do like this? Again. Capital DD minus ID RD capital. This is nothing but VDD minus of the drop across the resistor is my capital VDS. Okay. So it becomes capital VDS minus, see this is small v capital DS, which means the summation of these two. And this is minus small ID into R. Still I can rewrite this as capital VDS plus small VDS. Can I do like this? Provided this small VDS is minus ID into R. Correct? So from this, let's find out V out by V in. What is V out? V out is VDC, the small value of VDS, not VDC, VDS. Small value of VDS. Or V out is small VDS, V in is small VGS. Am I correct? I am giving this to be my input, and this is the amplified version of the signal, small signal which I give. Correct? This VDS we have got here as minus ID into RD divided by VGS. How do I still write ID? GM into VGS. Can I write like this? Why? Because GM transconductance of this MOSFET is I dou IDS or dou ID with respect to dou VGS. Am I right? This how ID current changes for the change in VGS. That is what transconductance. So if I want what is ID, is nothing but VGS into GM, correct? So I can replace this as minus GM into VGS into RD divided by VGS. You got this? Then here, striking off these two, this V out by V in, I can write this as gain, because V out is my output voltage, V in is my input voltage, which is the voltage. So gain with reference to voltage. After striking, you get GM times R. From this, what we conclude is the gain of the input signal VGS, which has been given to this common source amplifier, is a dependent factor on two things. One, GM of the circuits, directly proportional with GM of the circuits. Another one is RD, the resistance provided at the drain. So, if at all if I want to increase the gain, you can go by two ways. You can increase the GM, or you can increase the RD resistance which you have. And remember, the gain is nowhere related to any of the process parameter. Are you following me? Right? Because it purely depends upon GM into R. Right? That's it. So, what does this minus sign indicate? What does this minus sign indicate? The output is 180 degree out of phase. Say if I am giving input signal of this to be the amplitude, when it be V in, here output is going to be an amplified version of V in, where V out, it is 180 degree out of phase. So right, so V out is AV times of V, where AV is GM times R. So one important conclusion what we derive from this common source is, whenever I give input, the input and output are always 180 degree out of phase. The same circuit, if it is going to be in digital network, it can be called as an inverter. How? Very simply, take this. In analog, I call this as an amplifier, common source amplifier. Right? Where the gain also, whenever I give some input V in, the output is going to be amplified by this amount and you get the output. Only thing you need to make sure VGS is greater than VD, threshold voltage of the device. Now the same thing, the same circuit, if you take a digital network, the same circuit can be discussed like this. I am giving V in, right? I am taking my V out across VD, VD or VDS. Point is clear? If it is a digital, usually you will give 0 or 1, right? So 0 means 0 volts. 1, logic level 1 is say 3.5 volt or 5 volt, whatever it be. So let me consider as 5 volt. Now let's try to simply analyze what is going to happen. If I give 0 to the gate of, or 0 volt to the gate of MOSFET, what would happen? MOSFET, I am giving 0 to the gate, it won't get switch on. Why? VGS is not greater than VD. So when once I give 0 volts, MOSFET is going to be in off state. If this is in off state, what will happen to VDS? equal to VDD, because if this is going to be VDD, the same VDD will appear here, because this has been switched on. So you get V out, VDS or VOP. V out equal to VDD, which is logically equal to logic 1. Correct? Are you following me? The other way, if I am giving VDD or 5 volt, right? 5 volt as my input. So what's going to happen now? The device will come into on because you have VG is greater than VD. If the device come into on, what will be the potential at this point? Neglecting channel length modulation. What will be the potential at this point? VDD minus IDRD. Still you can straight away give the answer. What will be the value? 0. Why 0? I said there is no resistance between. I am neglecting the resistance between drain and the source. Are you following me? If that is the case, then it's mere switch like this. You are taking the output at this point. This switch has been closed. So you have RD here, VDD here. So actually you are trying to measure V out this zero potential. Got it? So this will make V out equal to 0, which is logically equal to 0. Now if I give VDD, that is logic 1, I get 0. If I give 0, I am getting. This is simply a circuit for a digital inverter. Of course, you can also construct a CMOS inverter. I am not discussing that. Simply by using one NMOS and a resistor, you can construct one inverter. Right? Because the earlier discussion somewhere while discussing with the PMOS, NMOS, right, CMOS culture, I said it could be acting as an inverter in that top. Right? But the same inverter could also be realized with a resistor and a NMOS. So the circuit remains the same, but where you are going to apply and in which context you are going to use it. If I give any voltage of an AC signal, then it could be used as an amplifier. In the digital network, it could be used as an inverter. Fine? The next one is, see, from the earlier discussion, we started with diode, then BJT, MOSFET. So we have used a diode for different application, and we have studied the physical structure of BJT and the MOSFET. We have studied what is the character relation guiding them, what are their characteristics. Then we have constructed a MOS device circuit or a BJT device circuit and biased using DC voltage, so that I try to put that in a Q point by giving appropriate value of VD, right, or a DC. Now the next discussion is, I am having this BJT or a MOSFET, whatever it may be. Time being I am considering with all my discussion with MOSFET, I am having a MOSFET. If I am putting this MOSFET in an amplifier circuit, what is going to happen? You will have a transistor sitting over there, MOS transistor sitting over there, and an input side loop and an output side loop. If you remember while discussing with the diode, we replaced that diode by its equivalent circuit. Like you have a switch there, a battery, right? So which could replace that for a diode. Am I right? Very similar to this, I am having a MOSFET, keeping the same MOSFET. I cannot proceed with the discussion of, or I cannot apply the Kirchhoff's current law or voltage law in my circuit. So I want to replace this MOSFET by a known elements like resistance, capacitance, current source, voltage source, right? That should reflect the characteristics of the MOSFET. Got it? That is called small signal models. Or I am trying to create a model. When I give an input of very small voltages, what is the equivalent model that could be replaced with this MOSFET? Are you following me? Right. So now we are going to discuss small signal models. When we consider the same thing, this is my gate, drain, source. Now I want to replace this MOSFET by an equivalent circuit which will reflect the characteristics of the same MOSFET. Am I correct? Right? Now let me draw. Let me take this terminal to be the gate terminal, this to be the drain terminal, this to be the source terminal. Fine? What is the basic property of the MOSFET? What does the MOSFET does? What is the role of a MOSFET? Yes? Voltage to? It converts the voltage to what? Current. Right? If you give any voltage VGS across this, it converts that to IDS. That's what we have said. IDS is K times VGS minus VDS the whole square. Or if it is in a linear region also, the IDS is a function of VGS and VDS. So basically this device MOSFET is to convert my input voltage to current. Where is the voltage given? It is given between these two terminals, gate and the source. So I would like to keep like this, VGS between these two terminals. Or it means the voltage which you are given in gate and the source. If I give VGS, it will generate me a current. The current that flows from drain to source. I represent that by a voltage controlled current source. This is like a diamond shape now. This shape is used for representing voltage controlled current source. That is IDS. What is the value of that IDS? In the notation with using GM times VGS. So I give VGS, it will provide me IDS which is nothing but GM times VGS. Am I correct? That is why I call this as voltage controlled current source. Now this voltage is controlling this current. Got it? That's all. It's a very simple model. Now you do this. I give a voltage and it gives me the current. Basically, neglecting channel length modulation. If I include channel length modulation, what will be the modification? What is channel length modulation? That is the non-linearity, or it's not non-linear, the dependency of IDS with respect to VDS, right? Shows me a linear variation of IDS with respect to VDS. I can model this as whenever there is a linear relationship that exists between I and V, I can model that as resistance, right? That's what we are seeing. R naught is dou IDS by dou VDS. Rate of change of IDS with respect to change of VDS. Now if I take channel length modulation into consideration, which means that there is a variation with respect to VDS for this IDS. So what I could do, I could replace or I could not replace, I could include a value of resistance between drain and source. Correct? Can I do that? Whose value is R0, where R0 is ID by VDS. So if I am including a resistance between drain and the source, it indicates that the variation of IDS with respect to VDS in this ratio. R0. So if I include this R0, that's all. Now it becomes a perfect model for a MOSFET. So very simply, this model is being generated very simply. If you give VGS, it will give me IDS, whose value is nothing but GM times VGS. And if at all, if you take channel length modulation into consideration, an extra resistance comes in. So wherever this MOSFET comes, I can simply replace by this. Wherever this MOSFET or anywhere in your circuit, I can replace this by a small signal. So this is called small signal model, and it also comes by the name pi model. Pi, because it resembles like a pi. You see, the shape will be resembling like a pi model. Understood? Remember again, it is a primitive model, means I didn't show in this line what is the capacitance that is existing between gate and the source, because we have read there will be a capacitance in that. What is the capacitance that exists between drain and the source, gate and the drain? All these things we have not included. If I include that, then it becomes high frequency model of this MOSFET. Means I am just trying to project how the MOSFET will react if the frequency increases. Then automatically this capacitance will come into picture. Thereby, this model may not give you the right value. So you are supposed to include all the capacitance at different points, right? Then it becomes a full-fledged model. One more thing also we have neglected in this for the sake of simplicity, that is bulk, right? So here we have shown only 3 terminal. So the bulk is under one terminal, which will be shown like bulk or body or substrate, right? Very similar to this, maybe in the first class I have said, IDS is a function of VGS, VDS and VDS. This will also have its impact on IDS as well as threshold voltage. So that and all we have neglected, right? Or we have simplified the model to a small signal model, something like this. If I try to include, this model will become a little bit hectic model, like you will have one more capacitance here, one more capacitance here, one more capacitance at this point, another one capacitance at this point. And now time being I am not taking that. Or if at all, if you read the frequency analysis of the amplifier, we will be taking all those into consideration. Time being we are not taking that into account. Okay? Very simple model. While I give VGS, it is going to be as well as. You can also have another one model derived from this pi model itself. What I am trying to do is, see the same thing. This is my gate. I am giving VGS between these 2 terminals, and you have a current source. This is GM times VGS, and you have a resistance R0. This is my drain terminal, and this is my source. Fine. Now I would like to make a small modification in this. Now time being, let me neglect the channel length modulation. I will add at the later date. Okay. Take this. Can I modify this circuit as can I do like this? I don't know. The same thing, because the same current flows over it, I can show like the same at the 2 points. Okay? Now look at it. Can I do like this? Can I do like that? Or I am joining the gate terminal to that node. Can I do that? One. How could I do it? There should not be change in the functionality of the circuit. It is in the saturation only. This circuit is only for this equivalent circuit.